Find the Fourier expansion for fx where fx is defined as minus pi when x lies between minus pi to 0 and x when x lies between 0 and pi, and hence deduce this series expansion. Okay, so first the Fourier series of any periodic function is given by a naught divided by 2 plus sigma n from 1 to infinity an cosine of 2n pi divided by b minus a x plus sigma n from 1 to infinity bn sine 2n pi divided by b minus a x. And this Fourier series coefficients are given by a naught is equal to 2 divided by b minus a integration from a to b fx dx. An is given by 2 divided by b minus a integration from a to b fx multiplied with cosine of 2n pi divided by b minus a x dx, and bn is equal to 2 divided by b minus a integration from a to b fx sine of 2n pi divided by b minus a x dx. So starting with first coefficient a naught, which is equal to 2 divided by b minus a. So here interval is minus pi to pi. So a is equal to minus pi, b is equal to plus pi. So b minus a will be 2 pi. Okay. So a naught is equal to 2 divided by 2 pi integration from minus pi to pi fx dx. And function is defined for different domains. From minus pi to 0 its value is minus pi, and from 0 to pi its value is x. So we will split this interval from minus pi to 0 and from 0 to pi. 1 upon pi minus pi to 0 fx dx plus 0 to pi fx dx. So value of a naught is equal to 1 divided by pi. From minus pi to 0 function value is minus pi dx. From 0 to pi its value is x dx. Now integrating these two integrals, minus pi x limits are minus pi to 0 plus x square divided by 2 limits are from 0 to pi. Now substituting these limits, 1 divided by pi minus pi into 0 minus minus pi plus pi square divided by 2 minus 0 negative pi square plus pi square divided by 2. So this expression is minus pi square divided by 2, which is minus pi divided by 2. So a naught is equal to minus pi divided by 2. So now calculating an, which is equal to 2 divided by b minus a, which is 2 pi, integration from a to b, which is minus pi to pi fx cosine of 2n pi divided by b minus a, which is 2 pi x dx. So this expression becomes 1 divided by pi integration from minus pi to pi fx cos of nx dx. Okay, again we will split this interval from minus pi to 0 and from 0 to pi. Minus pi to 0 fx is equal to minus pi cos of nx dx, and from 0 to pi its value is x cos of nx dx. Okay, so this expression becomes 1 upon pi, minus pi is constant, integrating minus pi to 0 cos of nx dx plus integrating 0 to pi x cos of nx dx. Okay, 1 divided by pi minus pi, integration of cosine is sine of nx divided by n, limits are from minus pi to 0 plus, here we can use successive integration, first function as it is x, integration of cosine of x is sine of nx divided by n minus differentiation of this x is 1 and integration of this expression is minus of cos of nx divided by n square, and limits are from 0 to pi minus pi sine of 0 divided by n minus sine of minus n pi divided by n plus, here upper limit is pi sine of n pi divided by n, so this expression becomes plus cos of n pi divided by n square, and lower limit is 0 times something is 0 plus cosine of 0 divided by n square. Okay, here we can use these two results. Sine of m pi is equal to 0 for all m belongs to integers. Sine of integral multiples of pi is equal to 0, and cosine of integral multiples of pi is equal to minus 1 raised to the power m for all m belongs to integers. Okay, so using these expressions, an is equal to 1 divided by pi, this expression becomes 0 minus 0 because sine 0 is 0 and sine m pi is also 0. Moving to the next expression, sine m pi is equal to 0, cos n pi is equal to minus 1 raised to the power n divided by n square, and negative cos of 0 is equal to 1 divided by n square. So this expression becomes an is equal to 1 divided by pi minus 1 raised to the power n minus 1 divided by n square. So this is the value of an. Now move to the value of bn. Bn is equal to 2 divided by 2 pi integration from minus pi to pi fx sine of 2n pi divided by 2 pi x dx. So this expression is 1 divided by pi integration minus pi to pi fx sine of nx dx. Again we will split this interval from minus pi to 0. Here function is equal to minus pi sine of nx dx plus 0 to pi x sine of nx dx. So now integrating this expression, 1 divided by pi, minus pi is constant, integration of sine nx is minus of cos nx divided by n, limits are minus pi to 0 plus, again using successive integration, first function as it is, integration of sine nx is equal to minus of cos nx divided by n minus differentiation of this x is equal to 1, and integration of this expression is integration of cosine of nx is equal to sine of nx, therefore negative sign as it is divided by n square, and limits are from 0 to pi. Okay, so 1 upon pi, this negative get cancelled with negative sign, pi cos of nx divided by n, limits are from minus pi to 0 plus minus x cos of nx divided by n, negative times negative is positive, sine of nx divided by n square, limits are from 0 to pi. pi cos of 0 divided by n minus cos of minus n pi divided by n plus minus pi cos of n pi divided by n plus sine of n pi divided by n square, and lower limit 0 times something is 0 plus sine of 0 divided by n square. Okay, so simplifying this expression, 1 divided by pi, cos 0 is 1, so 1 minus, because cos is a even function, so therefore this expression becomes cos of n pi divided by n plus cos n pi is equal to minus 1 raised to the power n divided by n, sin pi is equal to sin n pi is equal to 0 minus sin 0 is 0, 1 divided by pi, pi times 1 minus minus 1 raised to the power n divided by n minus pi minus 1 raised to the power n divided by n. Taking pi outside, so this expression becomes 1 minus minus 1 raised to the power n minus minus 1 raised to the power n divided by n. So this expression is bn is equal to 1 minus 2 times minus 1 raised to the power n divided by n. A naught is equal to minus pi by 2, an is equal to 1 upon pi minus 1 raised to power n minus 1 divided by n square, and bn is equal to this expression. Substituting this expression in Fourier series expression, so fx becomes a naught is equal to minus pi divided by 2, so this becomes minus pi divided by 4 sigma n from 1 to infinity minus 1 raised to the power n minus 1 divided by n square pi into cosine of nx, and last expression is sigma n from 1 to infinity bn is equal to 1 minus 2 times minus 1 raised to power n divided by n into sine of nx. So this is our Fourier series expression. Now we need to prove this deduction. Pi square divided by 8 is equal to 1 plus 1 upon 3 square plus 1 upon 5 square, so on. For this we will put some particular value of x from which we can find this series. Okay, so if we put x is equal to 0 in this Fourier series expression, so last term of this expression becomes 0 because sine 0 is equal to 0 and cos 0 is equal to 1. We only left with this expression. Here denominator is equal to n square, so we can find this series from here. Okay, so we have to put x is equal to 0 in this expression. For that we need to find the value of f of 0 because left hand side will be f0. But looking at this expression we can easily see that the function is discontinuous at x is equal to 0, because left hand limit of this function at 0 is equal to minus 5 and right hand limit at 0 is equal to 0. We will use average of this left hand limit and right hand limit, f0 negative plus f0 positive divided by 2. Okay, so left hand limit of this function at 0 is equal to minus pi and right hand limit f0 is equal to 0 divided by 2, so value is minus pi divided by 2. So where there is discontinuity in the function, we will use average of left hand limit and right hand limit. Okay, so put this value in Fourier series expression. So expression becomes f0 is equal to minus pi divided by 4 plus sigma n from 1 to infinity minus 1 raised to the power n minus 1 divided by n square pi. Okay, so f0 is equal to minus pi divided by 2 equal to pi minus pi divided by 4 plus. So look at this expression. Numerator is always 0 when n is equal to even number. When n is equal to even, so numerator of this expression is 1 minus 1, which is equal to 0. Okay, so this expression survive only for n is equal to odd. So n is equal to odd. Numerator is minus 2 when n is equal to odd, n square pi. So we will simplify this expression. Minus pi divided by 2 plus pi by 4 is equal to sigma n odd minus 2 divided by n square pi. So left hand side becomes minus pi by 4 is equal to, taking constant outside, minus 2 divided by pi sigma n is equal to odd 1 over n square. Pi square divided by 8 is equal to sigma n is equal to odd 1 divided by n square. So this expression is nothing but 1 plus 1 upon 3 square plus 1 divided by 5 square plus 1 upon 7 square. So this is our deduction.